So this is question number 17, and this question come in the year 2011 in CH Chemical Engineering. And the question with this original question paper, you can match it. It is question number 17, right, in the 2011. Now this question, let's read the question. Consider two black bodies with surface S1, area is 1 meter square, and S2, the area is 4 meter square. They exchange heat only by radiation. 40% of the energy emitted by S1 is received by S2. The fraction of the energy emitted by S2 that is received by S1 is, right. So here we have asked that the fraction of energy that is emitted by S2 that is received by S1, and the fraction of energy that is emitted by S1 that is received by S2 is 40%. And this question is related to radiation topic of heat transfer. Okay, so now let's solve this question. So first of all, you need to know the concept behind it. So let's first of all understand the concept that is involved here. So radiation, here we know that we have surface 1 and then we have surface 2, right. And first surface is doing some radiation, and radiation is done in all direction, right. That is the emission of a wavelength from all sorts in all direction, right. So now what is happening, that this radiation is radiating in all direction, and radiation is directly proportional to, or depends on, radiation depends on, first of all, the temperature. More the temperature, more the radiation will be, right. And the second is emissivity, right. Emissivity, how much emissive the surface is. But there is one point also that you have to consider, that not only these two, but when it comes for emissivity and radiation, when there is radiating, one body is radiating heat to another, there is also one factor that we have to apply, is the view factor. View factor means how much portion is exposed to the other body, or the how much portion that is visible of the other body with respect to the first body. So radiation is only happening with the radiation coming in this region, right. And this radiations are not involved in giving radiation to radiation exchange to this surface, right. So here view factor is also included. That's why we study view factor. So this question is related to view factor. And view factor, what is view factor? Let's solve this question right now. You have understand the concept. Let's solve the question right now. So this is S1, and the area for the S1 area is given 1 meter square, right. And S2 area is given 4 meter square, right. So view factor by reciprocatory law, we have area I, if Ij is equal to area J, if Ji. What this means? If Ij, what Fij stands? Fij means the fraction of the radiation emitted by surface 1 and accepted by surface J. The fraction of radiation emitted by surface 1 and accepted by surface J. The fraction of the total radiation emitted by surface 1 and accepted by surface J. So this is given here. We have given that the exchange of heat only by radiation, and the percentage of energy emitted by S1 and received by S2 is 40%. Means Fij is given to us, that is 40% means 0.4, right. And area 1 that is given to us, that is 1 meter square, and area of J, that is area of 2 S2 is 4 meter square. So now let's put all this in our equation that we are going to get is 1 meter square, and Fij is given 0.4 is equal to, it is given area J is given that is area of S2, that is 4 meter square, and if Ji means a fraction of radiation emitted by J, surface J, and accepted by surface I. So that is we have to calculate. That is what we have to calculate, right? So now by rearranging this equation, we are going to get 1 by 4 meter square is going to be cancelled out into 0.4, right? So this is going to be that is equal to fji, and this is going to be 0.4 and 4, and this is going to be 0.1 is equal to fji. So means that the energy emitted, the percentage of energy emitted from surface J to the surface I accepted by surface I is 0.1 in decimal, and in percentage it is 10%, right? So this is the answer. So 0.1 in decimal and in percentage 10%.